Hi everybody! Today, we will be discussing the concept of NMR. What is NMR?
Naked mole read, no marks received.
No, it stands for nuclear magnetic resonance. NMR works with the rotation of atoms. Each atom has protons and neutrons in the nucleus and electrons orbiting around it. For hydrogen, there is one electron in its electron orbital. NMR can work regardless of the number of electrons that are in the orbitals. So long as either proton or neutron number is odd, NMR can work. We can visualize a spinning proton as a rotating sphere of positive charge. This movement of charge generates a magnetic field called the magnetic moment that looks like the field of a small bar magnet. When placed in an external magnetic field, the preferred orientation is having the magnetic moment aligned with the external field. Having the magnetic moment oppose the external field is less favorable. In the absence of an applied field, all orientations are of equal energy. However, in the presence of an external magnetic field, the nuclei aligned with the applied field will absorb energy from electromagnetic radiation and change their spin orientation with respect to the field. The change in energy corresponds to the radio wave region of the electromagnetic spectrum. The frequency f is proportional to the strength of the magnetic field. This is a diagram of how NMR spectrometer works. To obtain an NMR spectrum, a sample of compound is placed in a sample tube and suspended between the poles of a permanent magnet in the spectrometer. Next, a radio frequency oscillator supplies the energy required for the nuclear spin to change. Finally, the change in spin states detected electronically by RF detector and signal is fed to a recorder to produce the NMR spectrum, which is a graph of absorbance against chemical shift. One important concept is that of chemical shift. As mentioned previously, the frequency at which a proton absorbs radiation depends on the strength of the local magnetic field around it. Even in constant external field, protons in different chemical environments absorb energy at different frequencies. This is because the local magnetic field they experience depends on the electrical and magnetic environment around them. To calculate the chemical shift, we can use this formula as shown, where delta x equals chemical shift of proton x, Fx equals frequency of absorption of proton x, Ftms equals the frequency of absorption of the protons in TMS, and F equals frequency of irradiation in megahertz. That's all for this video. Click the link above for more and do watch out for our second video on the applications of NMR.